So let's continue, my dear friends. So if you see in the last session, we were looking in the probability, right? So in this session, let's proceed further into probability and let's try to complete all the concepts and few sums on probability. So if you see, my dear friends, first we understood what is probability. So I said you probability means here we are trying to calculate percentage of future events. But basic thing is that you're not multiplying with 100. That's it. So how will you calculate probability? Probability will be favorable cases by total cases, right? Next, I said you that the sum of probability is equals to 1 and the range of probability is 0 to, right? 0 being unfavorable event, 1 being certain or sure event. And the probability always lies in between 0 to 1. Next, I said you earlier this probability was a branch of mathematics. Now it became the branch of statistics. Next, I said you we have two broad divisions of probability. One is subjective probability. Next is objective probability. Subjective probability is basically applied in decision making or used in management. Objective, classical, or priori probability is something where that's something which we already use it or which we do in this chapter. Here we already know the outcomes. Depending upon the outcomes, you are judging the probability, right? Then we have started with the definitions of probability. We have understood what is a random experiment. Any activity what you perform randomly or the activity where the outcomes are expected to occur in random is called as random experiment. Okay, like tossing a coin, rolling a die, picking a card, all these are random experiments. Okay, next after this we understood what is favorable cases, unfavorable case, or total cases. Favorable cases means cases which are favoring the event. Unfavorable cases, cases which are against the event. Total cases are sample space, that's total number of events what we have. Next, I said you probability of favorable cases plus probability of unfavorable cases will be equals to probability of total cases. Next, I said you probability of total case or probability of sample space will always be equals to 1. We have proved this also. So we can do probability of favorable cases is equals to 1 minus probability of unfavorable cases. Basically, whenever at least a condition is there, we'll be using this. Okay. We'll do it when we do it in the questions. Now, let's proceed further, my dear friends. Let's proceed to the next definitions. Leaving this definition 5, let's come back to all other definitions. Now, first, mutually exclusive events or disjoint events. What do you mean by mutually exclusive events or disjoint events? Mutually exclusive event means if one event happens, it prevents the happening of one more event. Okay, that's called as mutually exclusive events or disjoint events. Like say, for example, you're tossing a coin. When you're tossing a coin, you can get either head or you can get either tail. Means if head comes, tail will not come. If tail comes, head will not come. So these two are mutually exclusive events. Okay. Next, after this, say for example, I'm saying Mr. A is a voter in Calcutta. Mr. A is 13 years. Can these two things happen at one time? Obviously, no, sir. So these are mutually exclusive events. I'm telling Mr. X is studying philosophy, Mr. X is playing football. Can these two things happen at one time? No. Okay. So all these things which cannot happen at one time, they are called as mutually exclusive events or disjoint events. And the condition here is P of A intersection B is equals to 0 and P of A intersection B intersection C is equals to 0. So what are mutually exclusive events? The happening of one event prevents the happening of one more event. That's called as mutually exclusive events. Okay. And I hope the examples are clear. 3 examples. Head and tail is a mutually exclusive event. Next, Mr. A is a voter in Calcutta. Mr. A is a 13 years old. These two things cannot happen at one time. Next, third thing, Mr. A is studying philosophy and Mr. A is playing football. These two things cannot happen at one time. Next, mutually exhaustive events. Mutually exhaustive events means happening of events lead to sample space. That is, if you add the events, if it leads to sample space, we call it as mutually exhaustive events. Like say, for example, my dear friends, I'm telling you are tossing a coin. When you're tossing a coin, what's the probability of head? 1 by 2, sir. What's the probability of tail? 1 by 2, sir. Merge them together. What you will get? Resultant is 1. So I'll say head and tail are mutually exclusive. I can say head and tail are, when you're tossing a coin, head and tail are mutually exclusive and exhaustive. Okay. Why they are exclusive? Because sum is equals to 1. Why they are exhaustive? If head comes, tail will not come. And I can even say they are independent also. Independent because head and tail is not dependent on each other. I'll tell you later on. Next, I'm telling universal set is equals to 1, 2, 3, so on till 100. Next, I'm telling A is equals to even numbers. And next, I'm telling B is equals to odd numbers. Now, my dear friends, can I say if I do A union B, I'll get universal sets? Right? That's nothing but, again, these events A and B are nothing but, they are your exclusive events. Means if the happening of events leads to sample space, or if the happening of event unites to one, we call it as exclusive events. Okay. Exhaustive events means, I'll say that if one event happens, automatically other event gets rejected. Next. Equilikely or equiprobable events. Equilikely or equiprobable events means, my dear friend, the probability is same. If probability is same, we call them as equilikely or equiprobable events. Like I'm telling P of A is equals to P of B. Can I say head and tail are equilikely or equiprobable events? Yes, sir. Because their probability is same. Okay. If probability is same, we call them as equilikely or equiprobable events. Next, mutually independent events. Mutually independent events means events are not dependent on each other. Say, for example, you are tossing a coin. First time you got head. Second time, can you say that first time I got head, now pakka I will get tail? No, you can't say. Okay, because they are independent to each other. Okay, now you are attending a class. Your friend didn't come to the school. Now, if you say that since my friend didn't come to the school, I will come to the school. Sorry, since my friend didn't come to the school, I'll also not come to the school. Means here you coming to the school is depending upon a condition or depending upon the event. That's called as dependent event or conditional event. But I am telling, I don't care whether my friend comes or whether it doesn't come. Okay. Me coming to the school is not dependent on the probability of he coming to the school. So those are called as independent events. Independent events means happening of one event has no relationship with happening of one more event. Like say, for example, two students are writing an examination and they are not copying. Okay. Now, can I say those two are independent events? Yes, sir, they are independent events. One person passes or fails, it doesn't impact other person's score. Okay. So I hope it's clear. So what is the condition here? P of A intersection B is P of A into P of B. P of A intersection B intersection C is P of A into P of B into P of C. Okay. One minute. Yeah. So I hope these points are clear. So if you see, my dear friends, four to five important definitions. What are these important definitions? First one, exhaustive events. Yeah. Exhaustive events. Exhaustive event means P of A union B or P of A union B union C will be equals to 1. Next, exclusive events. Exclusive events means if one event happens, automatically other events gets rejected. P of A intersection B, comma P of A intersection B intersection C is equals to 0. Next, we are having equilikely events. Equilikely events means P of A will be equals to P of B. Next, we are having independent events. Independent events means P of A intersection B is equals to P of A into P of B. So these are most important points, my dear friends. Many times you can see them in the examination. He'll just ask a straightforward question on this. There's no twist and turns what he'll be doing on this question. Okay. Now see here one small example. I'm saying P of B, P of A but not B is equals to 0.4. P of A complement is equals to 0.6. P of B is equals to 0.3. He is asking what type of events A and B are. Now it's simple, my dear friends. He's telling P of A but not B. What is P of A but not B? P of A minus B is equals to 0.4. Next, P of A complement is 0.6. Then what is P of A? 0.4. So P of A minus B is P of A minus P of A intersection B is equals to 0.4. So 0.4 minus P of A intersection B is equals to 0.4. Now, can I cancel these both? Yes, I can cancel these both. So P of A intersection B is equals to 0. So can I say since P of A intersection B is equals to 0, can I say A and B here are exclusive events, my dear friends? Yes. So what do you mean by exclusive events? Exclusive events means intersection will be 0. That is, if one event happens, automatically other event will get rejected. Exhaustive events means union will be equals to 1. Equilikely means both will be same. Independent events means happening of one event is not dependent on happening of another event. So P of A intersection B is P of A into P of B. Now, my dear friends, we are studying classical probability or priori probability, right? Classical or priori probability. In classical or priori probability, it is said that all the basic events, like basic events means the small events. When you are tossing a coin, head and tail is a basic event. When you are rolling a die, 1, 2, 3, 4, 5, 6 is a basic event. When you are picking a card from a pack of cards, getting a red card, black card, or getting a heart, club, spade, all these are basic event, diamond, all these are basic events, my dear friends. The basic events in classical probability must be exclusive, exhaustive, and independent. It's a rule that all the basic events in classical probability that must satisfy these conditions. Only then they come under classical definition probability. Now, if you see here, tossing a coin, can you see what happened? Head and tail. If head comes, tail will not come. So they are exclusive. Union of head and tail is 1. So they are exhaustive. Head and tail has no dependency on each other. So they are independent. Okay. So I hope all these points are clear. Now, let's see one more example. I'm telling P of A union B is 2 by 3. P of A is equals to 2 by 5. I'm asking what is P of B? If A comma B are independent. Okay. Now, let's see how to solve this, my dear friends. It's quite simple. He's telling A and B are independent. So can I say P of A intersection B will be equals to P of A into P of B? Yes, sir. P of A intersection B is P of A into P of B. Now, what will be P of A union B? P of A union B will be P of A plus P of B minus P of A intersection B. 2 by 3 is equals to 2 by 5 plus, do we know P of B? No, we don't know. So let us assume it as X minus P of A is 2 by 5 into X. So 2 by 3 is equals to 2 by 5 plus X minus 2X by 5. Let's take an LCM. 2 by 3 is equals to LCM is 5. 2 plus 5X minus 2X. Let's do cross multiplication now. 5 into 2 is 10 is equals to 3 into 2 plus 3x. 10 is equals to 6 plus 9x. Take 6 to the left side. 10 minus 6, 4 is equals to 9x. So x is equals to 4 by 9. Okay. That is our P of B is equals to 4 by 9. So I hope all these points are simple, my dear friend. There's nothing much complication in this. So simple questions you will find in the examination in the same way. 1, 2 questions might be complicated, but they will be simple itself. Okay. Now just try these 2 questions and tell me the answer. Let me see if you can crack this. Example. P of A is equals to 3 by 5. P of B is equals to 2 by 3. I'm asking what is P of A union B if A and B are independent. I'll give you 1 minute. Just try this and tell me what is the answer. So I hope you got the answer. Let's check the answer. He's telling what is P of A union B if A and B are independent. Now, how will you get P of A union B? P of A union B is P of A plus P of B minus P of A intersection B, right? Now, my dear friends, he's asking P of A union B. P of A is 3 by 5. P of B is 2 by 3. Minus P of A intersection B is P of A into P of B. 3 by 5 into 2 by 3. Now 3 by 5 plus 2 by 3 minus 6 by 15. Okay. Now let's go ahead and let's take the LCM. LCM is 15. So 5 into 3 is 15. 3 into 3 is 9. 3 into 5 is 15. 5 into 2 10. Minus 6. So 10 plus 9, 19. 19 minus 6. So we have somewhere around 13. 13 by 15. So answer is simple. Answer is 13 divided by 15. Okay. Now, let's proceed to the next question, my dear friends. If there is any mistake, please make sure that you will correct it. Now, next example. He is telling A, B, C are mutually exclusive and exhaustive. Mutually exclusive and exhaustive. He is asking find P of B if P of A is equals to 2P of B is equals to 3P of C. This is the given question. Now, my dear friends, if you see in the question, he's telling A, B, C are mutually exclusive. Now, what is the condition of being mutually exclusive? Mutually exclusive means, can I say P of A union B union C is equals to 1? Yes, sir. Why I have taken 3 events? Because he's telling P of A is equals to 2, P of B is equals to 3, P of C. Now, what is P of A union B union C formula? P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C is equals to 1. Okay. Since he is telling they are exclusive and exhaustive, what do you mean by exhaustive, my dear friends? This intersection, everything will become 0. Unfortunately, entire this intersection is going to become 0. Right? Now, so I will say P of A plus P of B plus P of C is equals to 1. Now, what he is asking, my dear friends, he is asking you to calculate P of B, right? Can I say here P of A is equals to 2P of B? Yes, sir. P of A is equals to 2P of B. P of B is still same. Now, P of C. Can you see here 2P of B is given as 3P of C? 2P of B is equals to 3P of C. Cross multiplication, 2 by 3P of B is equals to P of C. So 2 by 3P of B is equals to 1. Let me go ahead and take LCM. What is LCM? LCM is 3. 6P of B plus 3P of B plus 2P of B is equals to 1. Okay. What is 6 plus 3 plus 2? 11P of B divided by 3 is equals to 1. Let's do cross multiplication. 11P of B is equals to 3. So P of B is equals to 3 by 11. Okay. So I hope the point is clear, my dear friends. It's simple. There's nothing much difficulty. So I hope all these examples are clear. Now let's come back to our definitions. So we understood exclusive, we understood exhaustive, we understood equilikely, and we understood independent. Now, before proceeding further, my dear friends, I'll show you one point. See. So just now I said you some useful conditions. In exclusive events, my dear friends, A intersection B will be equals to 0. That's the reason whenever you are having exclusive events, remember this, P of A union B will be equals to P of A plus P of B. P of A union B union C will be P of A plus P of B plus P of C. Means intersection, everything is 0, right? Next, if they are exclusive and exhaustive, sir, if they are exclusive and exhaustive, just now we have framed a condition. Can you see here if they are exclusive and exhaustive? What I have written here? P of A plus P of B plus P of C is equals to 1. This is for 3 events. Sir, what if only 2 events are there? P of A plus P of B will be equals to 1. Yeah. 3 events, P of A plus P of B plus P of C is equals to 1. P of A plus P of B is equals to 1. Next, P of A complement. What is A complement in sets? Obviously, sir, universal set minus A. But since we are doing probability, what is the probability of universal set or sample space? Obviously 1. So P of A complement will be 1 minus P of A. Okay. Next. So if I take P of A to the left side, P of A plus P of A complement is 1. Next, example of independent events. A and B write exam. So it is independent events, provided they don't copy. Next, A and B participate in a race. There's an exclusive events. Okay, because your union will be equals to 1. Next. Now this, when known that given that condition is there, we'll discuss that. If you are having or at least, we'll be using union. Already we have discussed it in sets. If you are having and both, we'll be using intersection. If you are using but not, you will be having A minus B. Already we have discussed this in our sets. Known that or given that is there, we'll discuss it now. So if you see, my dear friends, first point is completed. Probability is completed. Next is completed. Third is completed. 2 broad divisions. Next, random experiment is completed. Mutually exclusive is completed. Mutually exhaustive is done. Equilikely is done. Mutually independent is done. Next, if A and B are independent, everything in their life will be independent. Okay. If A and B are independent, my dear friends, everything in their life will be independent. A and A complement will be independent. A complement and B are independent. A complement and B complement are also independent. Everything is independent. Next. Now there is one condition for independent events. You can remember either you can do P of A union B as P of A plus P of B minus P of A intersection B, and P of A intersection B you can take as P of A into P of B, or else you can do 1 minus P of A complement into B complement. Even that will give you a same answer. If you don't want to remember this, it's fine. Okay, you can directly remember P of A union B formula, P of A plus P of B minus P of A intersection B, where P of A intersection B will be P of A into P of B. Okay, or else if you can remember this formula in the examination, even that is completely fine. Next, point number 10 also we have discussed. Next, point number 12 we have discussed. Now let's come to point number 11. Now what are odds in favor and odds in against? Odds in favor, my dear friends. Odds in favor means they are simply the ratio of favorable cases and unfavorable cases. Odds in against means they are ratio of unfavorable cases and favorable cases. Okay, they are simply odds in favor and odds in against. They are ratios of favorable cases and unfavorable cases. That's it. See here, let's understand. Example. I am saying probability of an event is 3 by 7, right? I'm asking what are favorable cases? 3, sir. What are unfavorable cases? Don't know, sir. What are total cases? 7, sir. So can I say unfavorable cases are 4? How did you get the 7 minus 3? So can I say odds in favor will be favorable cases is to unfavorable cases, Odds in against will be unfavorable cases is to favorable cases. Simple, sir. There is nothing much difficulty in this case. Fine. Now, let's see one example. See here. I'm telling odds in favor is equals to 3:5. I'm asking what is probability. How will you get probability? Favorable cases are 3. Unfavorable cases are 5. So total cases are 8. So probability is 3 divided by 8. Okay. So I hope this point is simple. There is nothing much difficult in this point. Now see here, there is one exam question which we'll solve now. It's a simple question. It's like this itself, the same point, but he asked it in a different way. Example, odds against of an event is given as Q is to P. He is asking what's the probability of an event. How will you get odds against? Unfavorable cases is to favorable cases. Unfavorable case is Q, favorable case is P, total cases is P plus Q. So probability of an event is simply P divided by P plus Q. Okay. This was an exam question. It was nothing much difficult. It was simple question. Now see here, my dear friends, there is one very good question what we'll solve. Let me take it out that. See, when we want to solve, you don't get questions. When we don't want to solve, we'll get so many questions. One minute, let me check. Yeah, got it. See here. This I say a favorite question again. It's a simple one. There's nothing much difficult even in this question. It helps us to understand many concepts. This one question. Example. Odds in favor of one student passing test is 3:7. Odds in against of one student passing test is 3:5. First thing he's asking probability of both passing. Next is telling probability of both failing. Now, my dear friends, test is given. I'm assuming that they didn't copy here. When test is given and then they didn't copy, can I say they are independent events? Both means both A and B. So he's asking P of A intersection B. What will be P of A intersection B? P of A into P of B. Why, sir? Because he's telling they are independent events. They are writing exam, right? So they are independent events. Okay. Now, see here, my dear friends. Odds in favor of A is given. Odds against B is given, but probability is not given over here. Okay. So for A, odds in favor is given as 3:7. Means favorable cases are 3, unfavorable cases are 7. Favorable cases are 3, unfavorable cases are 7. So what are total cases, my dear friends? Total cases are 10. Okay. So can I say probability of A passing is 3/10. Probability of A failing is 7/10. Probability of A passing is 3/10. Probability of A failing is 7/10. Now, there is some information given with respect to B. Odds against is given as 3:5. Means favorable cases are given as 5, unfavorable cases are given as 3, total cases are given as 8. So probability of B is equals to 5 by 8. Probability of B complement is equals to 3 by 8. See, odds against, right? So unfavorable cases to favorable cases. Odds favor, right? Favorable cases to unfavorable cases. Now, he is telling probability of both passing, that is P of A into P of B. So, I'll say 3 by 10 into 5 by 8. So, 5 ones, 5 twos. So, what is the answer? 3 by 60. Okay. So, I hope the point is clear, my dear friends. Probability of both passing 3 by 60. Now, can you tell me what is the probability of both failing? Probability of both failing, that is P of A will fail and B will fail. That is P of A complement into P of B complement. Probability of A failing, what is probability of A failing? 7 by 10. Into what is probability of B failing? 3 by 8. That is simply 21 divided by 8. Okay. Probability of both passing, that is A passing and B passing. Probability of both failing, A failing and B failing. Since they are independent events, intersection will be equals to A into B. Okay. So I hope these points are clear. So what are odds in favor? Odds in favor means favorable cases is to unfavorable cases. What are odds in against? Unfavorable cases is to favorable cases. Next, conditional probability. It's an important one. Conditional probability, 13. Compulsory, you will find one question in the examination. So what is this conditional probability? Conditional probability means if happening of one event depends upon happening of one more event. What I am telling, happening of one event is dependent upon happening of another event. Then it is called as conditional probability, my dear friends. Like I am telling, me coming to the school is dependent upon my friend coming to the school. Okay, means here the probability of happening my event is dependent on probability of happening one more event. If that event happens, this event happens. If that event becomes impossible, this event also becomes impossible. So probability of happening of an event is dependent upon a condition. If the condition becomes impossible, the main event also becomes impossible. That's what he's trying to tell. Okay, I'm telling probability of an event is dependent upon a condition. Me coming to the school is dependent upon a condition whether my friend comes to school or not. If he comes to the school, I will come to the school. If he doesn't come to the school, I will also not come to the school. Gone the case. Okay. If the condition becomes void, main event also becomes void. Okay. So here happening of an event is dependent on condition. So how will you write it? You will write it P of A by B, where A is the main event and B is the condition. And P of A by B will be equals to P of A intersection B divided by P of B. Okay. Now see here, there are some points what is telling here. Let us try to understand them. First, conditional probability P of A by B. What is A? Main event. What is B? Condition. So P of A intersection B divided by P of B. Now what is P of A complement by B complement? It will be P of A complement intersection B complement whole divided by P of B complement. You remember, my dear friends, De Morgan laws. P of A complement intersection B complement will be P of A union B whole complement divided by P of B complement. P of A union B whole complement is 1 minus P of A union B. P of B complement is 1 minus P of B. Okay, so same thing I have written. P of A complement by B complement is 1 minus P of A union B by 1 minus P of B. Next, if the events are conditional and independent, then P of A by B is equals to P of A, P of B by A is equals to P of B. Sir, if they are conditional and if they are conditional, how the hell can they be independent, sir? It happens. Sometimes this type of questions he'll ask. Though they are oxymorons, he'll ask in our examination sometimes. Let me take you through an example. Now P of A by B. What is P of A by B, my dear friends? P of A intersection B divided by P of B. Right? He's telling they are independent. If they are independent, what is P of A intersection B? P of A into P of B whole divided by P of B. Cancel. So what is left? P of B. P of A, sorry. So if they are independent, P of A by B is P of A and P of B by A is P of B. Okay. So I hope all the definitions are clear, my dear friends. We understood what is a random experiment. We understood what are exclusive events, what are exhaustive, what are equilikely or equiprobable, what are independent events. If A and B are independent, A and A complement, B and B complement, A complement and B complement, everything in their life will be independent, right? Next, we understood what are odds in favor and odds in against. Next, we are understood what are independent events. We have understood what are conditional events. Sorry, conditional events are also called as dependent events. And conditional events, my dear friends, the condition will be P of A by B will be equals to P of A intersection B divided by P of B. Next. Now, he's telling that if known that or given that is given, then it is a conditional probability sum. Now, sometimes, my dear friends, when we read a sum, we'll get confused. Okay, we'll not understand if it's a conditional probability sum or not. Just in that question, just see if that known that or given that word is given. If these two words are given, just blindly go ahead and think that they are conditional probability. When I solve few sums, we will look into that here. Okay, don't worry about that. I'll do this when we solve few sums. Next, some useful probability. Already single coin, single toss we have done, right? In a single toss, head and tail are exclusive, exhaustive, and independent. We have discussed this also. Next, two tosses are there. Even this we have discussed. Next, I said you sum of probability is always equals to 1. Next, three tosses are there. This also we have discussed. Next, when n coins are tossed, the probability of getting exactly R heads or tails will be NCR divided by 2 power n. Sir, what is this? See here. I'm tossing 5 coins. What is the probability of getting 3 heads? So how will you do this? I'm tossing 5 coins. What is the probability of getting 3 heads? Probability will be 5C3 whole divided by 2 power 5. What is 5C3? 5C3 is obviously 10, sir. 2 power 5 is 32. So if you're tossing 5 coins, then the probability of getting 3 heads will be 10 divided by 32. Okay. That is nothing but NCR by 2n. Next, dice. You're throwing a single coin. So you're throwing a single die. So what are the total cases? 1, 2, 3, 4, 5, 6. So total cases are 6. So what's the probability of getting 1? 1 by 6. Getting 2, 1 by 6. Favorable cases by total cases. Again, favorable cases by total cases. Favorable cases by total cases. So if you're tossing a single coin, if you're throwing a single die, the probability of getting 1 or 2 or 3 or 4 or 5 or 6 will be 1 by 6. Sir, what if you are throwing 2 dice? Now let's see what happens if you throw 2 dice. If you throw 2 dice, my dear friends, 2 dice, you will get 6 power 2 outcomes, that is 36. Just remember, sample space for coins, sample space will be 2 power n. Okay, that is if you toss 1 coin, 2 power 1 outcomes. If you toss 2 coins, 2 square. If you toss 3 coins, 2 cube. If you toss 4 coins, 2 power 4. Next, for dice, it will be 6 power n. For 1 die, 6 power 1. For 2 dice, 6 square. For 3 dice, 6 cube. For cards, 52 power n will be the sample space. For 1 pack of cards, 52 outcomes. For 2 pack of cards, 52 square outcomes. Okay. Now, what are these 2 dice, sir? 36 outcomes. Let me list you those 36 outcomes. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 4, 1, 5, 1, 6, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 2, 5, 2, 6, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 3, 5, 4, 5, 5, 5, 6, 6, 3, 6, 4, 6, 5, and 6, 6. Okay, so these are the total 36 outcomes what you will get when you go ahead and roll 2 dice. Now, my dear friends, can you see in this 36 outcomes, in how many cases you will get sum as 1? Sir, what nonsense you are talking? If you roll a die, how can you get sum as 1? It is impossible to get sum as 1. That's the reason the probability of getting sum as 1 is 0. Sir, in how many cases you will get sum as 2? See here how many cases you have sum as 2. 1 plus 1, 2. So probability is 1 by 36. In how many cases you will get sum as 3? In 2 cases. 3 by 36. Sorry, 2 by 36. In how many cases you will get sum as 4? 3 by 36. Sum as 5? 4 by 36. Sum as 6? 1, 2, 3, 4, 5. 5 by 36. Sum as 7? 1, 2, 3, 4, 5, 6. 6 by 36. Sum as 8? 1, 2, 3, 4, 5. 5 by 36. Sum as 9? 1, 2, 3, 4. 4 by 36. Sum as 10? 3 by 36. Sum as 11? 2 by 36. Sum as 12? 1 by 36. Okay, obviously, if you add all these things, you will get 36 by 36 because sum of probability is 1. Okay, so that's what is written here, my dear friends. Probability of getting sum as 2, 3, 4, 5, 6, so on is 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. Remember this. Next. Probability of same number on both dice. What are total cases? Total cases are 36. In how many cases you got same number on both dice? Let's check. 1, 2, 3, 4, 5, 6. In 6 cases, you got same number on both dice. So probability is favorable cases 6. Total cases 36. 6 by 36. Okay. So I hope the concept of 2 dice are clear. Right? Now, just try to answer me this question. We'll see how many of you can answer this. It's a simple one again. Example. 2 dice are thrown together. Probability that difference shown is 1. Probability that difference shown is 2. That's a given question. 2 dice are thrown together. The probability that difference shown is 1. The probability that difference shown is 2. Sir, how we calculate? Simple, sir. What are total cases here? Total cases are obviously 36. Now, favorable cases. In how many cases we have got difference as 1? Can you tell me? Difference shown is 1 in how many cases? Simple, sir. 2, 1, 1, 2. Still. 3, 4, 4, 3. Still. 2, 3, 3, 2. Still. 4, 5, 5, 4. Still. 5, 6, 6, 5. That's it. Still any other cases there where difference is 1? It can be positive or negative. Nobody cares. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 cases where you got difference as 1. So probability is favorable cases 10, total cases 36. 10 by 36. You want to simplify, you can simplify, or else it's your choice. depending upon the options, not our choice, depending upon the options. Next. Again, here favorable cases, difference shown is 2. In how many cases we have difference shown is 2? Let's check. 1, 3, 3, 1. Next, 2, 4, 4, 2. Next, 3, 5, 5, 3. Next, 4, 6, 6, 4. That's it. So in other case, you can think, sir, 5, 7, 7, 6. No, dude, there are only 6 phases in a time. That's it. 1, 2, 3, 4, 5, 6, 7, 8. So favorable case are 8. So probability is 8 divided by 36. The probability that difference shown is 2 is 8 by 36. So I hope the concept of dice is clear. So we understood the concept of coins. That is single coin, 2 coins and 3 coins. If more than 3 coins are tossed, what's the probability? NCR by 2 power n. Next, after coins, we understood the concept of dice. That is single die and 2 dice. Now let us understand the concept of cards. To see, my dear friends, in a card game, we'll be having total 52 cards plus 2 jokers. If question tells you to take joker, only then you will take joker. If not, total cases will always be 52. Because I don't know whether you know or not, whenever we play any game, we keep the jokers aside and we'll play unless and until they are included. Okay. These 52 cards, my dear friends, are divided into 4 suits. 4 suit. Suit means a pack of 13 cards is called a suit. 13 heart, 13 diamond, 13 club, and 13 spade. This heart and diamond, they are red in color because they are dangerous. Club and spade, they are black in color. Okay. So 52 cards, 4 suits. 13 heart, 13 diamond, 13 club, and 13 spade. Heart and diamond red in color, club and spade black in color. Next. This each suit has 13 cards. A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. A, J, Q, K, they are having picture on them, right? Like Ace, Jack, Queen, King has a picture on them. So they are picture cards. Okay. 2 to 10, they are called as numerical cards because there is a number on them. J, Q, K, Jack, Queen, and King. They are very honorable cards. They are very good cards. So we call them as honor cards. Okay. So from this set of 52 cards, if you pick up any 5 cards, my dear friends, we call it as poker hand. In examination, he'll ask you what is the probability of poker hand. Okay. Next. Now, what is the probability of picking 1 red card or 1 black card? First, total cases. 52 cards, I'll pick 1 card. Total cases. Favorable cases. How many red cards or black cards we are having? 26. So 26 C1. So favorable cases 26, total cases 52. 26 by 52 or 1 by 2. So probability of picking a red card, probability of picking a black card, both are equals to 1 by 2. Next, probability of picking 1 heart or 1 diamond or 1 club or 1 spade. It is 13 by 52 because what are total cases? Same 52 C1. Favorable cases 13 heart you are having, so 13 C1. So 13 by 52, which is equals to 1 by 4. So I'll directly ask the question, what is the probability of picking an heart? 1 by 4. What is the probability of picking a black card? 1 by 2. What is the probability of picking a queen? 1 by 13. What is the probability of picking an ace? 1 by 13. Okay. Next, take jokers only if question specifies to take. If not, please don't take that. Okay. So I hope all the points relating to probability are clear. So we have covered all the points, my dear friends, except that one single point. Now we'll come back to that. But once before proceeding further, let's do a few questions. Okay. Right now, what we'll do, we'll solve set number B and set number C probability sums. Then we will solve previous year questions. And then we'll go to random variables. Okay. Now, this is set number A from question number 48 onwards. I'm starting. All are simple, my dear friends. Taka will complete all and we'll proceed further. He's telling an unbiased die is rolled once. Only once you are rolling. The odds in favor of getting a point, which is multiple of 3. When you are rolling a die once, what are the total cases? 1, 2, 3, 4, 5, 6. Odds in favor. How will you get odds in favor, my dear friends? Favorable cases is to unfavorable cases. Multiple of 3. What are multiple of 3 here? 3 and 6 is a multiple of 3. 2. 2 things are multiple of 3 and 4 things are not multiple of 3. So what is 2 is to 4? 1 is to 2. Okay, simple question. Next. Bag contains 15 1 rupee notes, 25 2 rupee notes, and 10 5 rupee notes. So total 20, 30, 40, 50 notes are there. He's telling probability of not selecting 1 rupee coin. Okay. What are total cases? 50. Favorable cases. What are coins other than 1 rupee? These two are coins other than 1 rupee. So 35. So probability is favorable cases by total cases, which is equals to 35 by 50, which is 0.7. Next, he's telling A, B, C are mutually independent. If they are independent, what is A intersection B intersection C? P of A into P of B into P of C. So 0.3 into 0.2 into 0.4. How much you'll get? I get 0.024 you will get. Let's check. 0.3 into 0.2 into 0.4. Yeah, 0.024. Next. Now, if 2 letters are taken at random from the word home, what is the probability that none of the letters would be vowels? Okay. Total, how many letters are there? 4 letters are there. How will you take 2 letters from 4 letters? 4C2. What is 4C2? 6. Favorable cases. None of them are vowels, means consonants. How many consonants are there? H is a consonant, M is a consonant. How will you select 2 consonants from 2 consonants? 2C2, which is 1. So probability is favorable cases by total cases. Okay. Next, 52. A card is drawn from a pack of 52 cards. What is the chance of getting a spade or ace? Do you remember, my dear friends, I said if or is given, we'll be using union, and is given, we'll be using intersection. So spade or ace. So P of S plus P of A minus P of S intersection A. Now, how many spades are there? We know a pack is divided into 4 suits. What are the 4 suits? Yeah. Pack is divided into 4 suits. The 4 suits are, we are having club, diamond, heart, and spade. So how many spades we are having? 13 spades. How many ace we are having? 4 ace. In each suit, we'll be having 1 ace. Minus spade and ace. I have 1 card which is spade and ace. So what is that 1 card? C. 52 cards. We are having 4 suits. 13 club, 13 diamond, 13 spade, 13 heart. 13 spades are somewhat like this. A, 2, 3, so on. I mean, there is 1 card which is ace as well as spade, right? That's the reason I'm doing minus 1. So 13 plus 4, 17. 17 minus 1 is 16. So what is the probability? Favorable cases divided by total cases. 4 4s, 4 13s. 4 by 13. Okay. So I hope, my dear friends, 48, 49, 50, 51, 52 questions are clear. They are based on probability calculations. Now 53, 54, they are based on random variables. When we do random variables, then we can do that. Now 55. the probability of having at least 1 6. 1 minus no 6. I said you right, probability of favorable cases will be 1 minus unfavorable cases. So here also I'm doing, instead of whenever at least is given, we'll not do directly. Because at least 1 6 means you can have 1 6 or 2 6 or 3 6s. That's the reason I'm doing 1 minus no 6. So 1 minus, what is the probability of getting 6? You're throwing a 1 die. 1, 2, 3, 4, 5, 6. Probability of getting 6 is 1 by 6. Probability of not getting 6, in 5 cases you don't have 6, 5 by 6. So 1 minus 5 by 6. Is telling you're doing 3 times, so whole cube. So 1 minus 5 by 6 whole cube. So I hope all these set A sums are fine. So 53, 54, my dear friends, they are based on random variables. We'll come back to those random variables later on. So first, let us complete all probability related sums and some previous year questions. Then we can get back to random variable sums. Now let's come to set number B. He's telling 2 balls are drawn from a bag containing 5 white and 7 black balls. What is the probability that they would be of different colors? You're selecting 2 balls. Okay. There's a bag containing 5 white and 7 black. So total 12 balls are there. What are total cases, my dear friends? 12C2, that is 12 into 11 divided by 2. We have 66. Favorable cases, you're taking 2 different colors. That is 1 white and 1 black. How will you select 1 white? How will you select 1 black? So 5 into 7, 35. So probability is favorable cases divided by total cases. 35 divided by 66. Next. What is the chance of throwing at least 7 in a single cast with 2 dice? He's telling at least 7, my dear friends. You can do 1 minus 2, 3, 4, 5, 6. Or you can do at least 7. What do you mean by at least 7? At least 7 means you can get sum as 7, or sum as 8, or sum as 9, or sum as 10, or sum as 11, or you can get sum as 12. Or else you can do 1 minus 2, 3, 4, 5, 6. That's also fine. In how many cases you will get sum as 7? 6 by 36. Sum as 8? 5 by 36. 4 by 36. 3 by 36. 2 by 36. 1 by 36. 15 plus 6, 21 by 36. So what is 21 by 36? 3 7s, 3 12s. So answer is 7 by 12. Okay, simple sum. Next. Fourth one we have already done. 2 unbiased dice are rolled. What is the probability of getting no difference in points? No difference in points means 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. This concept. So favorable case are 6, total case are 36, 1 by 6. Next. What is the chance of getting at least 1 defective item if 3 items are drawn randomly from a lot containing 6 items, of which 2 are defective? See here, my dear friends. 6 items are there. In this, 2 are defective. Means can I say 4 are good? Yes, sir. Now, first total cases. You are selecting 3 items. How will you select 3 items from 6 items? 63. Now, what is 63? 6 into 5 into 4 divided by 3 factorial, which is 20. Now, favorable cases. He is telling what is the chance of getting at least 1 defective? 3 items are drawn. At least 1 defective means, my dear friends, can I get 1 defective and 2 good? Yes, sir. Or you can get 2 defective and 1 good. Yes, sir. Or can I get 3 defective and 0 good? Sir, how the hell you will get 3 defective and 0 good when only 2 defective are there? No. 1 defective and 2 good. 2C1 into 4C2. 2 defective and 1 good. 2C2 into 4C1. 2C2 is 1. 1 into 4 is 4. 2C1 is 2. 4C2 is 6. 6 into 2 is 12. So 12 plus 4, 60. So favorable cases are 60. So probability is favorable cases divided by total cases. That is 0.8. Next. A, B, C are mutually exclusive, independent, and exhaustive. What is the probability that they occur simultaneously? What nonsense you are talking, sir? If they are exclusive, how can they occur simultaneously? What do you mean by exclusive? Happening of one event rejects the happening of another event. That the events cannot happen simultaneously, right? So probability is 0. Next. Already 8th one we have done, my dear friends. In examples, we have done this 8th one. We got 3 by 11. Now 6th one. That 10 balls. Total cases are 10. If one of them is selected at random, what is the probability that the number would be an odd number greater than 4? Okay. Favorable cases. What are odd numbers greater than 4? 5, 7, 9. So favorable cases are 3. Total cases are 10. So probability is 0.3. 3 by 10 is 0.3. Next. Following are the wages of 8 workers. Okay. So total cases are 8. If one of the worker is selected at random, what is the probability that his wage would be lower than average wage? Okay. First, let's calculate average wage, my dear friends. What will be the average wage? 50 plus 62 plus 40 plus 70 plus 45 plus 56 plus 32 plus 45 whole divided by 8. Let me calculate the average wage. 50 plus 62 plus 40 plus 70 plus 45 plus 56 plus 32 plus 45 whole divided by 8. So average wage is 50 rupees. Average wage 50. Now how many people are having average wage less than 50? Let's count. 1, 2, 3, 4. So favorable cases are 4. So probability is favorable cases by total cases 4 by 8, which is nothing but 0.5. Next. 9th one also we have solved, my dear friends. I asked you what type of events they are. You said that they are independent. Next. 10th one. He is telling a bag contains 12 balls which are numbered from 1 to 12. Total cases are 12. Now favorable cases. What's the probability that the number on the ball would be multiple of 5 or 6? 1 to 12, can you tell me how many are multiple of 5? 5 ones 5, 5 twos 10, 5 threes 15. Next 6, 6 ones 6, 6 twos 12, 6 threes 18. So only 4 are favorable cases. 4 are favorable cases. Total cases are 12. 4 by 12, which is 1 by 3. Okay. Next. Question number 11. This question number 12 also we have solved, my dear friends. Already in examples we have solved this. If you remember, I said you this. There are independent events. I said you P of A union B. Either you can do P of A plus P of B minus P of A intersection B. Or if you remember, I said you can even do 1 minus P of A complement into P of B complement. Let's check whether this will satisfy or not. 1 minus A is 3 by 5. What is A complement? 2 by 5. B is 2 by 3. What is B complement? 1 by 3. So 1 minus 2 by 15. So 15 minus 2 by 15, that is 13 by 10. Perfect. This is also fine. You can do either this one, because in examples we did this one. Now I showed you this one. Anything you can do, you'll get the same answer. Okay. Next, given for two events A and B, P of A is 3 by 5, P of B is 2 by 3, P of A union B is 3 by 4. He is asking P of A given B or P of A by B. What is P of A by B, my dear friends? P of A intersection B divided by P of B. P of B is given as 2 by 3. Now, what is P of A intersection B? Obviously, sir, P of A plus P of B minus P of A union B, right? So what is the LCM here? LCM will be 5 into 3 into 4, 5 into 3 into 4, which is nothing but 60. Okay. So 12 into 5 is 60, 12 into 3 is 36. 3 into 20 is 60, 20 into 2 is 40. 4 into 15 is 60, so 15 into 3 is 45. So 36 plus 40 minus 45. 31 by 60. So 31 by 60. Okay. So be careful, my dear friends. 31 by 60 is not the answer. 31 by 60 is P of A intersection B. Now, 31 by 60 into 3 by 2. So how much it will be? 31 into 3 whole divided by 60 whole divided by 2. It is 0.775. So answer is simply 0.775. 31 by 60 here is P of A intersection, which is not the answer. He's asking P of A by B. Okay. Next. 13th one will not do. There is some error in that. Next. 15th one, we have already done this in examples. Now, let's do this 14, 16, and 17. First, let's do question number 14. He's telling P of A complement union B complement is 5 by 6. P of A is 1 by 2. P of B complement is 2 by 3. He's asking P of A union B. Okay, let's do it. Here. So question number 14, my dear friends. P of A complement union B complement is given as 5 by 6. What is P of A complement union B complement? I hope you remember this De Morgan laws. P of A intersection B whole complement is 5 by 6. So can I say P of A intersection B will be 1 minus 5 by 6, which is 1 by 6. Next, P of A is 1 by 2, fine. P of B complement is given as 2 by 3. Then can I say P of B is equals to 1 by 3? How, sir? 1 minus 2 by 3 is 1 by 3. P of A intersection B we have, P of A we have, P of B we have. He's simply asking you to calculate P of A union B. P of A union B will be P of A plus P of B minus P of A intersection B. So 1 by 2 plus 1 by 3 minus 1 by 6. So my dear friends, what is the LCM here? LCM is obviously 6. 3 plus 2 minus 1. So 4 by 6, which is nothing but 2 by 3. Simple question. Yes, sir, simple question. Nothing much difficulty here. So 2 by 3. Next. 16th one. P of A is 2 by 3. P of B is 3 by 4. P of A by B is 2 by 3. He's asking P of B by A. Don't write 3 by 2. Okay, that's wrong. P of B by A will be P of A intersection B by P of A. Be careful. Question number 16. P of A is 2 by 3. P of B is 3 by 4. P of A by B is equals to 2 by 3. What is P of A by B, my dear friends? P of A intersection B divided by P of B is 2 by 3. Right? Now I want to calculate P of A intersection B. Let me do cross multiplication. P of A intersection B is 2 by 3 into P of B. 2 by 3 into P of B is 3 by 4. Cancel, cancel. 2 ones, 2 twos. That is 1 by 2. Now he is asking you P of B by A. P of A intersection B whole divided by P of A. 1 by 2 whole divided by 2 by 3. So 3 goes to the numerator, 3 by 4. I hope you know this. A by B by C by D will be AD by BC. The same thing. So what is the answer here? Answer is simply 3 divided by 4. Next. P of A is A, P of B is B, P of A intersection B is C. So he's asking what is P of A complement intersection B complement. What is A complement intersection B complement, my dear friends? It is simply P of A union B whole complement. That is 1 minus P of A union B. So 1 minus P of A plus P of B minus P of A intersection B. So 1 minus, what is P of A? A. P of B, B. P of C, C. Sorry, A intersection B, C. So 1 minus A minus B plus C. 1 minus A minus B plus C. So simple, sir? Yes. Next, 18th one. For 3 events A, B, and C, the probability that only A occurs. I said you this already. Only A means A minus B minus C. Or else you can even write it as P of A intersection B complement intersection C complement. I hope you remember, my dear friends, in sets we understood that if intersection and complement comes together, we can interchange it to minus. So P of A minus B minus C can be written as P of A intersection B complement intersection C complement. Next, question number 19. He's telling it is given that a family of 2 children has a girl. Okay. What is the probability that other child is also a girl? First, let's take total cases. 2 children are there. They can be girl, girl, boy, girl, or girl, boy. Sir, can't they be boy, boy? No, sir, they can't be boy, boy, because he's telling already there is one girl. So total cases are 3. Favorable cases. Other child is also a girl. In how many cases 2 girls are there? 1. Okay. So favorable cases are 1. Total cases are 3. So probability is 1 divided by 3. Next. Again, 21, 22, and 23, they are based on random variables. Let's do 20. 2 coins are tossed simultaneously. What is the probability that the second coin would show a tail, given that first coin has shown a head? Given that he's telling. So it's a conditional probability sum. Okay. Probability that the second coin should show a head. Second coin should show a head, given that the first coin has shown a head. First coin has shown a head. So P of second coin has shown a head intersection first coin has shown a head divided by P of first coin has shown a head. Let's see, 2 coins are tossed. If 2 coins are tossed, what are the outcomes? Head, 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 tail, tail head, tail tail. Second coin should show head, first coin should show. So second coin should show tail, sir, not head. Tail. Two coins are tossed simultaneously. What's the probability that the second coin would show a tail given that first coin has shown a head? Perfect. Now, second coin has shown a tail, intersection, first coin has shown a head. Now, can you see in how many cases second coin has shown a tail and first coin has shown a head? There is only one case, sir. Second coin is tail, first coin is head. First coin shown a head. In how many cases first coin has shown a head? 1, 2. 2 cases first coin has shown a head. So 1 by 2, 0.5. Understand it carefully. He's telling second coin has shown a tail by first coin has shown a head. So A intersection B divided by B. In how many cases first coin has shown a head, head, tail? So 2. Okay. Now, we'll solve all the sums under set number C. There is no issue. But first, let me solve this sum. And then I'll come back to conditional probability. Two sums are there in additional question bank. We'll do those two sums. He's telling a number is selected at random from 1000 natural numbers. So total cases are 1000. How many numbers are there which are multiple of 7 or 3? I said you, my dear friends, in progressions also, how to count numbers which are multiples. 7 or 3 means 7 union 11. So 7 or 11 means 7 union 11. 7 numbers divisible by 7 plus numbers divisible by 11 minus numbers divisible by 7 and 11. How will you count how many numbers are divisible by 7? Simply you will do 1000 divided by 7. You will get 142.8, but don't take that decimal. How many numbers are divisible by 11? 1000 divided by 11, you will get 90.90, but don't take that decimal. How many numbers are divisible by 7 and 11? You will divide by 77. 12.98, but you will not take that decimal. So 142 plus 90 minus 12. So 220. Favorable case are 220, total case are 1000. So probability is 0.2. Okay. Even this 10th sum, my dear friends, before proceeding further, remember I said you probability of favorable cases will be 1 minus probability of unfavorable cases. He's telling what is the probability that the problem would be solved. Can I do 1 minus no solving? So 1 minus A not solving, B not solving, C not solving. What is A solving? 1 by 3. So not solving, 2 by 3. B solving, 1 by 5. Not solving, 4 by 5. C solving, 1 by 2. Not solving, 1 by 2. 2 to cancel. 1 minus 4 by 15, which is equals to 11 by 15. 11 by 15. Okay. All sums will solve. There's no issue. But just randomly I'm taking up so that our concept will be clear. Yeah, this one I got the conditional probability sum. 14th one is a conditional probability sum. And there are two questions in additional question bank also on the basis of conditional probability. That also will solve now. It's a fantastic question, 14th one. See this, my dear friends, 14th one. He's telling for a group of students, 30% failed in physics. People failed in physics is 30%. Failed in chemistry is 40%. And failed in at least one of the two subjects is 50%. What is the probability that he passed in physics? If failing probability is given, passing he is asking. So P of P complement If it is known that he failed in chemistry, if it is known that he failed in chemistry. What is the probability that he passed in physics? Failing is given, but he is asking passing. So complement. If failed in chemistry, so normal. So P of P complement intersection C divided by P of C. What is A complement intersection B? B minus A. You remember whenever complement and intersection comes together, intersection changes to minus. So P of C minus P. When I'm telling intersection changes to minus, don't write P of P minus C. Complement is there to P. So it will be P of C minus P divided by P of C. So P of A minus B, P of A minus P of A intersection B whole divided by P of C. Now, my dear friends, at least one of the two subjects is given. At least means union, right? P of P union C is given as 50. P of physics 30. P of chemistry is given as 50. Then what is P of P intersection C? P of P plus P of C minus P of P union C. 30 plus 40, sir, this is not 50. So 30 plus 40 minus 50. 70 minus 50, 20. So P of C, 40 minus 20 divided by 40. So 20 by 40, which is simply equals to 1 divided by 2. 1 divided by 2. So I hope this conditional probability sum is clear, my dear friends. He's telling what is the probability that he passed in physics. It is known or given is given means it's a conditional probability sum. Okay. Next. See here, I want to solve one more conditional probability sum. See here, my dear friend, these two questions, 103 and 104, they are also based on conditional probability. Even 102 and 101 are also based on conditional probability. First, let's see 101. For 102, a player has 7 cards in which 5 are red. Out of these 5, 2 are kings. A card is drawn at a random. The probability that it is a king if it is known that it is a red. But the king, it is known that it is a red. King cards are 2. King and red cards are king and red cards are 2. Red cards are 5. So 2 divided by 5. King and red cards are 2. Because in these 5 red, you are having 2 kings. Means these kings are king and red. So P of K intersection R is 2 and P of R is 5. Next. In a class of 40% students read mathematics. In a class, 40% students read mathematics. P of M 40%. 25% students read biology. There are 15% students who wrote both maths and biology. The probability that he reads mathematics, it is known that he reads biology. He reads maths. It is known that he reads biology. P of M intersection B divided by P of P. 15 divided by 40. 5 3 is 50. Sorry, 5 3 is 15. 5 it's 4. Yeah, 15. Probability that he reads maths, it is known that he reads biology. So 15 by 25, sorry, not 40. Okay. So 5 3 is 15, 5 5 is 25. Probability that he reads biology if he reads mathematics. P of B by M. P of M intersection B whole divided by P of M. M intersection B 15, P of M 40. So 5 3 is 50, 5 8 is 40. So 3 divided by 8. Okay. Simple questions, nothing much difficulty. Okay. So that's it, my dear friends. Balance things we'll do in the next session.